Initial information and project setup. As mentioned in the presentation, at the initial stage, we have PDF documents provided by the architectural company. These documents describe in detail the architect's requirements for how the construction should look. Additionally, they include colored visuals that help us better visualize the final structure. We also received a top-down construction plan, which is drawn with sufficient precision. Using this plan, we will create the initial basic framework. Starting the component creation, let's begin by creating a new component. To lay the foundation, we navigate to the Manage section and then click Import to bring in our selected DWG drawing. First, we need to determine the plane in which we will be working. In this case, let's assume we are working in the XY plane, so we import our drawings into this plane. Now, we have the foundation ready. Creating the main volume. To create a 3D volume, if you are somewhat familiar with parametric control systems like AutoCAD, you know that the process involves drawing a contour and then extruding it based on the defined shape. Firstly, we go to the XY plane and project the geometry. Since we currently have a 2D drawing, we specify which edges are relevant for creating the future skeleton geometry. We'll proceed with our choice by clicking the Finish Sketch button. Then, we select Extrude, choose a profile, and set the height. Based on our specific architect's documentation, the structure must be 700 millimeters high. We apply and create the new extrusion to our chosen profile. When extruding other profiles, you can use the first one as a reference for a quick and precise workflow. This forms the primary concept of the lower structure. Now we can see that we have created multiple main volumes that make up the basic skeleton. Using the same principles, we continue constructing the entire structure. Maintaining associativity and updating drawings. It is important to note that the drawing used as a base retains its associativity. As long as we do not deliberately break this link, we can open the drawing in AutoCAD and make necessary modifications. For example, if we receive a requirement to extend the structure by 600 millimeters on both sides, we can simply stretch it to the required length on one side and then the other. After making and saving these changes, we return to the inventor and see an indication that updates have been made. After we confirm the updates, we can notice that all dependent volumes adjust accordingly, splitting the structure into modules. Now we need to split the entire body into separate modules that we will refine further. The process is straightforward. We begin by creating a plane that passes through specific edges. Then we perform the splitting operation by choosing the Split tool. The recently created plane will act as the splitting guide for the chosen block to be separated into smaller parts. We can identify that the block named Solid 3 turned into two blocks, Solid 11 and Solid 12. We can rename the blocks for convenience. If further splitting is required, we repeat the process with another plane. This method allows us to easily divide the entire structure into required segments. Managing the modules. Now that the structure has been divided into separate modules, we need to properly organize them. Each block should be treated as an individual component, and for that there is a dedicated functionality that allows us to make and store all these components in the desired location. We create a new component set, give it a name, and complete the splitting process. Final outcome. The resulting assembly looks similar to the main skeleton, but now each component can be opened individually and edited separately. For example, we can modify a component's content by adding new elements or sketches, such as decorative handles. Additionally, we have the work geometry here and can include parameters, allowing for more flexible control over model properties. At any point, we can edit the content of any component. For example, remove unnecessary sketches, while keeping only the required elements. By following this approach, we can break down a conceptual model into separate modules, refine each module individually, and ensure synchronization with the main skeleton structure.